Oh, and in this podcast, we're going to talk about how to write net ionic equations. On the AP exam, you must write net ionic equations for all your equations. So if you have any compounds in your equation that will form ions in aqueous solution, then you have to show them as ions. And the two reaction types we're going to look at today are precipitation reactions and acid-base. Single replacement, which is also known as redox, we'll do when we get to the electrochem. Okay? So the steps involved in writing a net ionic equation start off by writing a simple molecular equation and balancing it. And then the step that takes the most work is identifying, write the balanced ionic equation, which involves deciding which compounds will form ions and must be shown as ions. Then we can simply eliminate spectator ions, and what we should have left is the balanced net ionic equation. Alright, so here's how we decide what to break up into ions. Things on this list get ionized: strong acids, strong bases, and soluble salts. Strong acids, there's a list of 6 of them that you should have memorized, right? The strong bases, they're the group hydroxides of the group 1 metals and the 3 largest group 2 hydroxides. And then the soluble salts, the salts that you have to have memorized: the alkali metals, ammonium, nitrate, and acetate. And you need to recognize that sometimes acetate is written like this. Everything else does not break up when we leave it as a full compound. Okay? So if we have an acid and it's not on this list, we're going to consider it weak and not make it into ions. If we have a base and it's weak, and we're going to assume it's not on this list, it's going to be weak. If we have an insoluble salt, now most salts are insoluble, and we're going to assume for our sake and for the AP exam sake that it does not contain one of these ions, that it is insoluble and form a precipitate. Now everything else is considered a non-electrolyte or a weak electrolyte. These are what make strong electrolytes, okay? And that includes anything that it's a molecular compound or a gas or pure element, any organic compounds. Okay. Sometimes it's a little bit confusing because you might have something that's a soluble ion like acetate or ammonium, and if it's part of an acid or a base, then what dictates is the acid-base rule. So for instance, I have HC2H3O2 is acetic acid. It has the acetate ion, but it is a weak acid, so we do not show that as ions. Just like if I have ammonium hydroxide, it is a hydroxide, it's a base, it's a weak base, and even though it has ammonium in it, we're going to draw it as a compound and not as ions. The other thing you have to memorize is that there are 3 compounds which immediately decompose and produce a gas and water. Okay, so ammonium hydroxide, if you pull water off, what you have left in that compound is ammonia. Carbonic acid, if you pull off water, what you have left there is CO2. And sulfurous acid, if you pull off the water, what you have left is SO2. So you have to memorize these, and if you run across them, you have to write them as this and not as this. Alright, so let's take a look at our examples. We have 4 examples to work with. So let's think about the reaction type. It's either precipitation reaction or an acid base. And I don't see H's or OH's, so this is going to be a direct replacement precipitation reaction. So if I look at what's going to happen to this, the silver and the potassium will switch places. Okay. And when they do that, I'm going to end up with the silver with the chromate. Plus the potassium with the nitrate. Now potassium's a +1, nitrate's a -1, so I only need 1 potassium here, so I need 2 of those, and because I have 2 nitrates here, I'm going to need 2 of those. Okay, so now I have to decide, so that's the molecular equation. Now for the total ionic, I have to decide what I'm going to break up into ions. So let's take a look one at a time. Silver nitrate contains nitrate. I'm going to break that up. Potassium dichromate contains potassium. I'm going to break that up. This is a salt that does not have any soluble ions, so that's going to be a solid, and I will not break it up. This has both potassium and nitrates, both of which are soluble, so I'll break it up. Alright, so let's go ahead and write that net ionic. So that is going to give me, so I have to be careful because I want to always make sure that I am showing the number of ions. I have 2 here, so I have 2 silver plus, and you must show the charge, plus 2 nitrates, plus 2 potassium pluses, plus a dichromate ion. Okay. And I'm going to make, this is a solid, so I will not break that up. Plus this will break up, and I'll have 2K plus 2 nitrates. Now I have to decide what my spectators are and eliminate them. I'm going to do that with a red pen. So let me see, I have 2 potassium here and 2 here, 2 nitrate here and 2 nitrate here. So for my net ionic, I'm going to write what I have left over after I eliminate my spectators. So I have 2Ag plus Cr2O7, and I get AgCr2O7. And this is a solid, and these are aqueous. And after you've done enough of these, what you'll notice, especially with precipitate reactions, that I end up forming a solid, and most people after a while can figure out what that solid's going to be. And then I can just write that as a product and put what ions I need to form that. But most people for a while need to do the full ionic before writing the net ionic. But in the end, the AP test only requires that you do this. You don't have to do the preceding steps, but it's fine if you do. Alright, so here we have ammonium hydroxide plus acetic acid. Okay, so what's going to happen here is I'm going to make, I'm just going to write down here. So what I'm going to make is ammonium with the acetate, and the OH and the H are going to form water. And I always write water as a liquid when I'm writing an acid-base reaction. Now let's think about what we're going to break up into ions. Even though this has ammonium, it is a weak base, so I am not going to ionize that. Acetic acid, even though it has the acetate ion, it is a weak acid, and I'm not going to dissociate that. Ammonium acetate is a salt. These are both soluble, so I will dissociate that. And I never dissociate water. It's a molecule, right? Alright, so let's write the net ionic. So I end up with NH4OH plus HC2H3O2. And I'm going to form ammonium plus C2H3O2 minus plus water liquid. And I'm going to look for spectators. And as it turns out, I don't have any spectators. So my total ionic equation and my molecular ionic equation in this case are exactly the same. Alright, let's take a look at this. So I have a base and an acid. So this is an acid. Whoops. This is an acid. Let's try that again. An acid-base reaction. And it's going to be like a double replacement. I'm going to end up with sodium sulfate and water. I needed 2 sodium, so I'm going to put that there, and I'm going to end up with 2 waters. Alright, so I have a strong acid, a strong base, which I will write as ions, a strong acid, a soluble salt, but not my liquid water. So let's write the full ionic. So I have 2Na plus 2OH minus plus 2H plus. And even though the H2SO4, we know if we just put it in water that it ionizes in 2 steps, but it doesn't do that. Whoops. It doesn't do that when it's with a base. I keep doing this. When it's with the strong base, that strong base is basically pulling this H plus, both H pluses off and forming water. So it's really the Chatelier going on there. Okay. So let's continue this net ionic. Plus my sulfate ion, and I'm going to form 2 nitrate sodium pluses plus a sulfate minus plus 2 waters. Alright, so let's take a look at our net ionics. I'm going to use purple to do that. I have 2 sodiums. I have sulfate. Alright, so let's see what I have left. This is my net ionic. I have 2OH minus plus 2H plus, and that's going to give me 2H2O liquid. And as you notice, 2's, 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 I can simplify this. And that's going to give me water. This is a liquid. These are aqueous. Okay. This right here is the net ionic equation that it turns out works for all strong acid, strong base. It's the net ionic for every one of them. Every time I have a strong acid and a strong base, I get this net ionic. You don't have to memorize that because you can figure it out by writing it. Alright, I think we got it. This is the last one, yeah. Here we have hydrogen sulfide and barium hydroxide. This is an acid, this is a base. Okay, so I'm going to write this as an acid-base reaction. Alright, so when I do my double replacement, I'm going to end up with barium sulfide plus 2 waters. And I'm going to assume this is a solid. So H2S, it's a weak acid, so I am not ionizing that. Barium hydroxide, strong base, I'm ionizing that. Barium sulfide, it's a solid. There's nothing soluble there. And this is a liquid, it's a molecule, so I'm not going to separate that. So I write my total ionic equation. I have H2S plus barium plus 2 hydroxides. And I get barium S, and that's a solid, plus 2 waters, and that's a liquid. So let's see if I have anything I can eliminate, and I don't, so my total ionic equation and my net ionic equation are exactly the same. Alright, we're going to stop right there.